Hi guys, I hope you good since last video. I want to build a TUI in Rust so that I can learn more about it. I have an idea in mind for my Kubernetes cluster, but before that I need a project that will help me to understand the gymnastic behind the TUI creation in Rust. Something small, but that would give me something to start with or to refer to for my Kubernetes Rust application. So in this video, we are going through the code base and then running the TUI. It will be a file reader with some simple key bindings for the user to navigate it. And also we have learned recently how to use input terminal parameters. So we would use that here as well to indicate a path corresponding to the file that we want to read. I've left a link in the bio for the students who want to learn AI by doing, beginner devs who want to think at a service that they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download on the video. Link is in the pinned comment and video description. Get it now for more help, check our houses. Also, please like and subscribe. Thank you for your support. Open your terminal. Let's get started. Code review, our learnings. So we're going to go through the code and see the different steps and try to understand it. I've already put some comments. If we need more, we're going to add some more. So let's check the cargo.toml on the dependencies. We have cross-term for the backend, Ratatui for the frontend, for the TUI actually. So here cross-term for backend, and Ratatouille. I don't know if it is a French package. So for the TUI, and I added also this error so that I can also try to see how we can create some custom errors. I'm trying to add up on my learning. I've been skipping on errors, so I'm just going to check how I can do that. So I'm just going to clean the project, get rid of the binaries and all, and we're going to start it together later on in the video. But before that, we're going to check the different files that we have in the project. I'm just going to restart here NeoVim so that we can have the updated folder without the target. Okay, now it's good. It's minimal and it's not complicated, so we can check it from here. We've seen the cargo.toml, and those are the files inside the source directory. CLI, error, main, and state. So for the errors, I'm using this error, which is here the dependency that I've added. And from this error, we're going to be able to build decorators. Okay, so we derive error and debug. We use an enum called app error decorator, in which we can put our custom error message like a format. If more to put, we can use some different positions like indexing. And after here, just an example, how we can format this and put the decorator above any struct. Here we have the cross-term error, and we're going to use the standard IO error on it. And the 0 is going to be filled like here in the example with the message. I had this one, but I have commented it out because I'm not using it. Error here, unknown key. When we exit. So this one here, I tried to customize it, but I don't get it printed. So I didn't fix that one yet, because I might need to put actually those curly braces and the 0 and indicate what I want to print. So here I just put exist with error, but it's okay. I did it on purpose. All good. Let's just add all good. So this probably will not print, but that's the error that we want when we exit the TUI. And after we have here the CLI error, this one is going to print the string. This one is going to work for sure. So I'm still discovering. And here we have the CLI. So we use it as a crate. Don't use the mod. That's for the error that we can use from here. That's why I'm using use crate. I don't use mod. So no more modules. Just a file next to the other. So you can call it and import it using that like that. Use crate error, app error. And after here we have the standard environment variable and the path buff. It's going to be returned as a result. So here that's how we are going to, in this project, get the path. That is going to be an argument passed into the CLI. Okay, so env args. The nth one, it's a position. It's like when you induce your indexings. So here, let's say you have a 0, 1, 2 index. Okay, so here we just got the 1 position 1 index to get the input parameter. Because I'm gonna just do cargo run and add this path, and we're gonna be able to pick up on this path. If there is something, it's gonna be okay. So the result is gonna be pass buff. Gonna have everything in the buffer. Or if there's nothing in, we're gonna get the CLI printing missing file path. And after we need a string here, as we said when we define the error. That's why we used here into. Okay, app error, CLI into, because this is a str, %str. Let me try to go in error just to show you where it is, just to rely in what I've shown you before, CLI string here. So that's why we use into in the other side, and it's going to be printed. So I might need to implement something like that for the exit one in order for it to work. Okay. So we've seen get path from CLI. Now the states. We have a struct called app, takes the lines as a vector, string vectors. Okay, and here we get an offset, the usize, in order to get those lines visible, but we want to manage how many lines we want to see. We implement to the app struct the function new, just to create a new one, which is going to get the vector lines, and the buffer is going to start at 0. And here is the little bit tricky part. In order to get that, we need to scroll up and scroll down. So we're going to create here functions, and we're going to set the offset using the saturating sub. You can use saturating add also. So this is to subtract. So I'm just going to slowly comment out and just to show you different steps. So here the scroll with usize saturating sub are making sure that it's not less than 0, as usize should be always positive, so we don't get any error or panic because of that, compiling errors. So we scroll up and down by the n offset, but never passing 0, so it's never going to be negative. Okay, so here maybe this one is for after. I didn't show, this is for the scroll down. take a mute self, so we want to mutate it. Same as above, and after here we use the lines, the length of the lines. So we want the last line index. That's why we're using the lines here on the length. Saturating sub, that's why we're using that with a 1 inside. And in the comment, that's why I'm going to explain the 1. And after the offset, self-offset plus the n, okay, the use size and the minimum last line index. Okay, so all that is for it to not go over the maximum. So here the mean is to not overshoot the end, so to pass over it. So we use subtracting sub to do the logic, but it exists also its counterpart, as I said before, saturating add. So to subtract or add, so as use size 0 minus 1 panics for on the flow, as use size can't be negative, we need the safe subtraction using saturating sub. I always say subtracting. So saturating sub with a 1, so that 1 minus 1 is 0. That's why I'm adding the little 1 there, so it never goes on the 0. Also, be careful as the use size will load its largest value every time, so we need to control that. We need to limit it using the range 0 to the length of those lines minus 1. So that's why we use the lines here, the length minus 1, subtracting 1, okay? Saturating sub, so we're going to subtract 1. Right hand side. So we have the right hand side, just to say RHS, on the left hand side LHS. So the result, if the left hand side is bigger or equal to the right hand side, we do the calculation. Otherwise, we just set it to 0. So that's what basically we're doing here. We don't want it to be negative. So we want to make sure that the left hand side of the calculation is always bigger than the right hand side. Okay? So left hand side bigger than or equal to the right hand side. That's how we make sure that it's not here, the semi-comment out, it's not negative, okay? So that's how I've pictured it. That's how I can see it in my brain and understand it. So I hope that this talks to you. Okay, otherwise we return 0. Let's go down here and we have the last comment. Therefore, the saturating sub will safely return 0, not negative panic for use size. Okay, so we're not going to get into the case in which it's going to be negative and we are going to get this panic on the app crashing. So you get this if the right hand side of the calculation is bigger than the left hand side of the calculation. Okay, so this is how I've explained it, but we can maybe make it a bit more understandable here. So not negative panic for use size in the case of having right hand side bigger than left hand side. Okay, so we have our scroll up, scroll down. That's what we're going to use. In the main here, we take those files on the side that has module error, state, CLI, and after we can use from those modules app from state and app error from error. We also use custom event, disable mouse capture, enable mouse capture, the key code, terminal enter alternate screen, leave alternate screen, on the Ratatui, we just import all like that. But I wanted also to know what are the import one by one. So I've commented it out, but you can also, at the beginning, maybe it's better to not use those stars and just use the right imports, so you see where everything is from. So we have frame, terminal, cross backend, cross-stem backend, because Ratatouille is using cross-stem as a backend. But you can customize the backend also to have another one. After here we use env, file system, IO, standard output, and the pass buff. And here we use our get pass from CLI. We return a result. In case of error, we return our custom app error. And after here, I'm using question mark for the get pass CLI. Same here for the lines, question mark. So here, let's explain for the question mark. You see here, it's going to return an error already. It's a result. So we can just use here a question mark. So if it is okay, it's going to go in sum. If it is not okay, it's going to go into the error. So let me just comment out my explanations so we can just go through it. I want to see it into the details, load the file, the user passes. Okay. So question mark is deterministic error propagation. If okay, return X, otherwise error E returns E. As the function is returning an app error, it is a valid way of handling production grade code error. Okay, so you will see me trying to learn about errors in this little project at the same time as I'm learning about the TUI and how to get that running. Okay, so here we use %pass to look cleaner, but it is cheaper to use it directly the pass. So we don't need because we don't need it after. So here are the lines. I'm just gonna save the lines here, %pass, and after we're gonna start here. I'm just gonna comment this out so we can read. Iterator for %str and splits on line returns. Okay, so we're gonna get those lines from our file that we want to read like that, and each line %str is gonna be cloned. So that's how we're gonna get a string. So breaking str lifetime tie. So you can, or you can use it like that. Okay, you can use a closure if you want. So that's how the map here is going to be getting those %str to owned, which is going to be mapping those lines to become strings, and that's how we can collect those into a vector string. Because that's what we want. We want a vector string with lines inside. So we can loop over those lines and show those in the TUI. So we put the lines in the app and offset start at 0. So we create a new one, as we've seen the implementation of new. It's a mute, it's a mutable, because it's going to be modified. Okay, and here we set up the terminal. We prepare the standard output managed by cross-term backend. This is from Ratatouille. It's a mutable standard output. We start the process iterative TUI by entering alternate screen, enabling the mouse capture, and enabling the raw mode with cross-term terminal. We load the standard in the cross-term backend. Okay, standard is here, standard output. Now we have our backend. We load the backend holding on the standard output in the terminal from Ratatui to get the terminal output. Type is mut term, so it's a mutable terminal of type cross-term backend, holding the standard output type in. Terminal is from Ratatui constructor, use Ratatui terminal, and use Ratatui prelude star, the one we use it to get all. So that's what we used above. So that's where we get a terminal from. That's why at the beginning it's better maybe to not use the stars, so you know where everything is from. And that's how we create the mutable terminal. We put the backend in, question mark. Here we run the loop of a mutable app type vector string that we have created above. Okay, so the terminal and the app is going to go into this function run that we're going to see after. The app is here, holding the lines in a vector. Okay, those lines, this vector that we have collected. Let me close this. And after we restore everything, we stop the process, disable raw mode, execute, backend mute, leave alternate terminal. So where is the backend mute that we've used before? Here we have the backend terminal mute, and here we just return it empty. Terminal show cursor, and after we return this object that we just created here, the loop. So I didn't show you yet that function run, but you can see just under here, line 83, that's the one we're going to check, and use the key binding. So there's just two functions, you see, small functions. So run takes a mutable terminal, which is this one here with the backend in and the standard output, and then app mutable is going to return a result with our app error, and here we're just going to use the loop, the rest loop, and put everything in. Interaction and render every frames f, which are mutable also. Okay, and UI f, so UI is another function here. That's the one which is going to be painting the TUI, so drawing everything. We do a match, so matching on the event, pressing up, for example K. Okay, we match. If there's any event here, we return, we exit with the exit error that we have created here. But I don't get the sentence being printed, so I need to maybe find how to index a string to it. Maybe I should have used the same as the CLI a string, but it's okay. And after we have scroll up 1, scroll down 1, or page up 10, or page down 10. So the n, which is entered into the scroll up and scroll down, this is the usize, which is going to be determining, let me close this comment, going to be determining the offset. I'm passing through those calculations for it to not overshoot the top or the bottom. Okay, so we just use a match pattern, and we show to the user that here in the UI will be displaying text and output of file lines in app struct, which have the state lines and the offset to the TUI. So this takes a frame, which is a mutable f here, and it takes also an app. And after here, we're going to be creating this layout with the header, body, and footer, cutting it in a vertical direction, so chunk, split, buffer, header, body, footer. So the length is 3, so we have 0, 1, and 2 has an index. Each chunk n will be type rect, okay, U16. So as it implements copy, we don't need to use the ampersand. So now I'm going to check if stuff are implementing copy or not. Like boolean, for example, implement copy, so you don't need to use the ampersand for boolean. So the value will be copied. It's cheap to pass it by value. Rect is the struct from Ratatui, so that's where it's from. And that stores the X, Y, width and height. It marks the area on the screen where the widget with the render. And after here we can just do our own layout like that. So here I just used 3, header, body and footer, but you can cut it horizontally also, and you can do whatever you want. Put as many boxes as you want. You just build those boxes like that. So the first one is length 1, the last one is length 1, so it's going to be just 1 line each. But the one in the middle is 1, meaning it's going to take the whole area. Okay. After here we split the buffer, the frame. So split size, that's what I used, but it didn't work. Compiler told me to use split area. Okay. So I'm using split area and it works. It's good. So here the header layout formatting for static header, no scroll. So the header here is static, doesn't move, but inside the line is going to be actually displaying the offset. So it's going to be kind of showing the lines. It's going to be always redrawn. So you're going to have the effect of that being rewritten. Feel like the lines are passing from 1 to 2. After here we just use the offset, the area, the height. We use it as a usize, that's how we pass it in. And we render this header. Okay, the header is here. Is the chunk 0, the header. The body is the 1, chunk 1, and the footer is the chunks, the index 1, no 2, footer 2, so index 1, and here footer index 2. Okay, so chunk 0, that's for the header. And after here we have the body. Don't forget the app is from app vecstring, where we have those lines. I'm going to do an iteration on those lines. I call the variable visible. That's the line that we can see. We skip the offset. We take the chunk 1 as usize. Okay. So chunk 1 has a height here, you see. The min is going to take the whole space. But there is a size to it. We can cast it to a usize. So as I told you before, the rect from Ratatouille is holding those X, Y, and height and width. So that's how you can play with it. Okay. And after here, we use .clone. So app lines iter, skip the offset, take the usize of the chunk, and after we clone here. So it's just a trick to pass from an ampersand string to an owned string. Or you can use a closer. And after here we collect the vect, but in another way than before, because I haven't seen it. But yeah, I mean, I have seen it, but I haven't used it. So I wanted to use it. You can use vecstring, but you can also use it like that with an underscore. And it's going to be here. It's going to be just the same type as what is being yielded by what is above. So join needs an owned collection, so owned strings. That's what we got. That's why we have to use the clone. So that's the owned. The body here, we pass in the visible parameter with all those lines, and we're gonna use the Ratatui render widget to pin it to the TUI. So we're gonna do same for the footer with a little here tutorial. Go up and down, K and J, page up, page down, Q to quit. Okay, and after we can style it. That's how we can use the kind of CSS of TUI in Ratatui. Use the colors, dark gray. That's the only color that I'm going to use, white and dark gray. Run the frame, which is the area number 2, chunks 2. And we just align everything at the center. Let's have a little break. Please like and subscribe during the break. And after we're going to run our first REST TUI running directly. And after I'm going to be running the binary also. So this is how it's going to be done. Cargo run. That's what you normally do. Let's run this. And after you put the path. Okay, so here I put the path. It's an int on the next project that I'm going to do. I have already made some searches and wrote some notes. And we're going to just pass through that file because it's a very long file. So that's good. We're going to be compiling here everything as we have cleaned. So it's going to be recreating this target folder. Just wait a few seconds together. And here we go. First line, the buffer, the header, line 1 to 35. That's what we got here. And here are the different paragraphs. And you see down there it's gray for the little tutorial. Here, those ones, they're the last lines. Length 1, index 0, this is for the header. And after here I can just press those buttons. If you go in another terminal you might get a little glitch like that, some errors. But I just scroll down like crazy. It's back to life. And you can see how those lines numbers are changing. They bring, that's why it's good to have Rust. It's pretty quick to reprint this TUI, to redraw it. So it can follow the +10, +10, +10, +10, -1, +1, and so on. And this is the U size, representing the size of the min 1. So whatever it's in the middle, the body. Okay? And you can go up and down. It won't go over it. It's not going to exit and go to the sky or down to the lava of Earth. Okay, so you can see here what I might be presenting you in the future projects, in the future videos, I mean. Okay, and the errors here. This one doesn't print. Exit. I might need to customize it to put a string inside exit. So here is just a bare exit that I'm using. And that's why it's not printing. You see, error, exit down there. That's it. There's no custom sentence. Okay, we have the target folder. It's been created. The app works. So now let's say you want to just export the binary so you can run it anywhere. Here's the binary. how do you run the binary? You go into the folder, binary doesn't work like that. We got an error, custom error, CLI, missing the path. This one prints. And you put the path after you need the argument, otherwise you get the error. And it works the same. Okay? So that you've seen both ways. Now using this knowledge, I'm going to take you through a bigger Rust TUI project, and we are going to analyze it step by step in next videos. It is pretty interesting and minimal, with only what we need just to do the job. Hope that you liked this video, and we'll start using it for your mini local applications and automations. We've seen how Ratatui can help us build some simple TUIs. I still need to see it a little bit more, and would definitely use it in the next Rust project, in which I want to build an automation that would discover my cluster and upgrade all the components, controller, workers, nodes, as I've done that manually or through some bash scripts that I've created. This will be nice and interesting for people who have followed our Kubernetes series, which is very different from what you can find on YouTube. So stay tuned for next. Let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.